Hello everybody, welcome back to another video in the series Crystal Growing. Now, as I said earlier, we are doing crystal growing today, but this is a continue video, so if you haven't watched the first 8 videos, I would recommend you do so before watching this one. I will put a link up here so you can check it out, but anyway, let's begin. So, as I mentioned in the last few videos, we will be using copper sulfate as a growing salt. So, nice blue color. I've just added some more water because there was still some crystals on the bottom that weren't dissolved. So, but anyway, I reckon it's good enough to start filtration. So, for filtration, I take my yellowed cup, which I should replace, but I am not because I'm too lazy. Now, I'm going to pour all of that solution in carefully. Yeah, the rest looks clean enough, doesn't it? Yep. There we go. So, we take the funnel, we set it over the beaker, just like that. We take filter paper, and we stuff it in. Now, I would recommend using the industrial filter paper, but if you're like me who are just too lazy to buy it or can't afford to, don't worry. Coffee filters will also work. So I will take this plastic cup and I will slowly pour it in. Do not pour it in too fast or else the solution will drip down into the sink and I do not want to waste this stuff. Alright, so any nasty stuff should be caught at the bottom, and I already see some yellow particles at the bottom. But anyway, it looks pretty clean. So, but I'm still gonna do it anyway. And, ooh, spilled a little bit. Alright, sorry everyone. Just a little solution spill. That shouldn't be too big of a problem. And it's nearly finished. Yep. We'll just have to wait for it to drip through. But, alright. So, now, I have loads planned for you guys, and I'm pretty sure you guys are getting really bored of me doing crystal growing videos, so do not worry. I already have a couple ideas. I've already ordered some new chemistry materials. I have actually asked my viewers to give me ideas because I'm constantly running low on ideas. So, yeah, but anyway, looks like this dilution is nearly done, and we got like around 300 or 350 milliliters of solution. But let me clean this up for a bit. There we go. So let's set that there, and let's make sure you can see it. So there we go. It is nearly done. We got some yellow stuff at the bottom, which I do not know what it is. If you do, leave a comment down below so you can let me know what it is, because I'll be interested to know if we can do some stuff with that. It's like, as you can see, it's covered my cup. So yeah, this stuff is very annoying when you go crystal growing because it actually affects the purity of the crystal. So always filter. And as I've said countless times, we have the well, I use on the tap water to make my solutions, but the best is distilled water, the ones that you would buy in your average supermarket. But this thing is done, so you can take it out, set it aside, take this out, give it a good rinse, and set that aside as well. In fact, I'm just going to put it under my cupboard. Okay. So, I'm going to give this another stir to make sure that that this remaining powder will dissolve. Now, this solution looks a little bit too light blue, you know what I mean? Because if you watch my previous videos, they are much darker. That is because I highly suspect that this solution is not saturated yet. Which means if you are not the sciencey person, unlike me, saturated is a scientific way of saying that that a solution is so full of compounds that it cannot dissolve anything else. So, yeah. So we have to wait for the saturated. I'll put our seed crystal in because we do not want our seed crystal to get dissolved again because it took me so long to get that seed crystal started. Okay. But I'm pretty sure that you are not here to watch my crystal growing video because it's kind of getting old. So I decided to do some more fun with these solutions. So if you will excuse me, I will grab some paper clips and staples. So just wait a second, please. Okay, everyone. Sorry for that. If I was away too long, but if you were away, you can always skip ahead. And yeah, we got a sewing needle, which could be really interesting. So we also got a clip here, so that should be interesting. Now, I've done this a few times. I've already done this one time, but I'm pretty sure that this thing is so satisfying to watch that you may want to watch it again. So I'm gonna pour 50 milliliters of solution out from the main jar. We're gonna throw these things in the solution and hope that they get plated in a thin layer of copper. Now, for those of you who do not understand, like, Ethan, what the heck are you talking about? Now, because the copper, this solution is a salt, is a dissolved variant of the salt, of the main salt of copper sulfate. It will actually plate objects that are made of metal and are less reactive than copper, which in this case I used iron. And maybe a trace of aluminum is there too. But, so this is how I'm going to do it. We can leave it overnight, and we'll see tomorrow if it gets coated in copper, just like that paper clip from last time. Now, I'm pretty sure you want to find out how this thing works, so I'm just going to take you to my whiteboard and I'll quickly explain. Now, just wait. Here's my whiteboard. Now, okay, I just shut the door behind me, and I'm going to extend the pole so that I can actually use it. Now, okay. Let me just adjust this one. Okay, so now that we have our whiteboard, I'm going to use blue marker, especially for copper sulfate, just like I do in the previous videos. So let's say that we have a solution of copper sulfate. So let me quickly draw that. So we have a solution of copper sulfate. There. So we've got a solution of copper sulfate. CuSO4 is the chemical formula for copper sulfate, for those of you who do not understand. Now, when copper sulfate reacts to iron, or anything that is less reactive than it, in this case we're going to use iron, we will actually get a thin plating of copper on the iron surface, because iron is more reactive than copper. So we'll draw ourselves an iron ball, and then we'll cover it up with thin blue lines. So that is what you get when iron is combined with copper sulfate. Now, I might do this later on, but copper sulfate is also used in electrolysis, which is the the more efficient way to make this, so you don't have to sit there for a whole day and wait for your results to turn up. So, yeah, man, this thing is really bothering me. Let's just get rid of that. Let's just get rid of that paper. Okay, so let's say that we have a bin which is filled to the brim with copper sulfate. So let me just quickly label that. There. So you got copper sulfate there. And in order to do electrolysis, you need alligator clips. So for that, I'm going to use red or reddish brown. So we have our alligator clips in here. Now, the electrolysis cannot be done without electricity, hence the name. So let's connect these with a wire into a battery cell. And now it is important that I show you the positive and negative marks. So, okay, now we have, this, which is, I'm going to use blue. For this one, we have on the negative electrode, we've got some copper, a bar of copper. I know copper is not blue, but I have to use the orange for iron. So, whoops. So, wait, let's make this rod out of iron. So, when we turn on the switch, we will actually be able to get an electric current to actually pass through that wire and into the electrode, into each electrode. So, now, as I've already explained, iron is more reactive than copper. So, the iron will naturally want to go to the copper because it is more reactive, and opposites attract because this one's negative and this one's positive. So on this, the positive ions will actually leave and join the negative ions. So, and as you can guess, the opposite happens for the copper. So the negative ions will actually want to leave. There. Okay, now, I'm not really sure if I got this wrong. Please let me know in the comments, because I always like to hear your ideas, and I respect them. So, let me quickly erase all that, because I'm pretty sure you already understood that. Now, copper is very, very conductive. So, we have, say, a copper wire that is, as you may know, that is extremely conductive. It's the most affordable conductive material after the tin, and silver is the most conductive, but a bit too expensive to afford in large quantities. So now, because copper is very, very conductive, you'll actually, and that's why it is a very good conductor. So that is why electricity can actually pass through it. Now, if you use something like a non-metal, say, I don't know, I actually don't know. So why don't we say we use a piece of sulfur? Sulfur is a non-metal. Non-metals tend to have extremely low conductivity. So that is why we use copper in our wires, which I'm pretty sure that you all know. So let's erase that, and I think that I'm going to leave you off today right here for the whiteboard part. So let me quickly put the lids on my markers so they don't dry out, and so I can use them next time. But let us return to our bathroom. Let me lower the camera. So there we go. Yeah, you can already see a little bit of copper on the very edge of the needle. So, tells me that you got some good stuff going. And now I'm going to give this thing a good stir, because that's what you always want to do when you're growing solutions. You give it a stir so that if it is not saturated, it will the remaining pieces will actually go in to the go into the solution, and with a nice copper sulfate crystal in there. But I don't want it, so it's going straight back. Now, I want to thank you for watching this video, because this is where I want to end off, because, well, I've got some other things to do in my time, and I'll be preparing the next video for you guys. So, as always, stay safe, and thanks for watching.